everyone, welcome back to Shulin Anubha Academy. I'm Anubha, a corporate trainer working with some leading companies like Oracle, Wipro, UST Global, HCL and many more. Today we are diving into an essential topic in dynamic programming, the longest increasing subsequence or LIS for short. Whether you are preparing for coding interviews or just love algorithm, this is a must-know concept. So let's get started. First, guys, let's understand what the longest increasing subsequence is. Given an array of integers, okay, the LIS is the longest subsequence that is strictly increasing. For example, the array which is given to us, okay, the elements are 10, 22, 9, 33, 21, 50, 41, 60 and 80. So one of the longest increasing subsequence is 10, 22, 33, 50, 60 and 80. So the length is 6. So we will be taking the same example and trying to solve this using the various approaches. So guys, the first approach is the naive approach. Okay, so one way to solve this problem is using the recursion. Okay, we will be considering each and every element. We'll include it either or in the subsequent or exclude it. Okay, so unfortunately this approach will take exponential time complexity, that is order of 2 raised to the power n, which is impractical for the large arrays. So guys, now let's go with the dynamic programming approach to find the longest increasing subsequence length. Okay, so guys, dynamic programming will be providing you the complexity of order of n square, so which is much lesser than the exponential complexity. Okay, so we will be considering this for this example array or the vector what I have created here. Okay, this code is written in C++. Guys, you can write the same code in Java, Python. The logic would remain same, only the syntax is going to be changed. Okay, so here this reference of the vector I have given in this function where I am calculating the length of my LIS. Okay, so now guys, the three things you have to take it into the consideration. The first thing is the dynamic programming array what I have created it here, and I have initialized it to 1. Okay, so this array will be storing the length of the LIS ending at each index. Okay, so why we are initializing it with 1? Because the smallest LIS ending at each element is the element itself. Okay, so that is why I am initializing it with 1. Now what we are doing here, we are using the iteration. We are iterating through each element. For each element we are comparing it with all the previous elements and we are going to update our DP array. Guys, the DP array you can put any name. Here I have just referred it according to the dynamic programming. And in the last here we are updating, we are finding the maximum value in the DP array, okay, which is representing the length of your longest increasing subsequence. So guys, what we are doing, let us say initially though I am just checking, like if your vector is empty, then of course it will be returning 0. Okay, otherwise what I am doing, I will be initializing my DP array first of all with 1. So I have initialized it with 1 for all the indexes. Okay, now what I'll do, I will be starting from the index 1. That means the element 22 I am going to start. Okay, and I will be comparing with all the previous elements of your DP array. So what I'll do, I will be comparing it with 10. Okay, so when I have compared it with 10, okay, so I have found that 22 is greater than 10. Okay, since 22 is greater than 10, then there will be the updations in the DP array. If any element is less than 10, then we are going to, like, we are not going to update your DP array. Otherwise, we are going to update it. Okay, so how the updations are being done? According to the maximum value. Either the maximum value is with the current index positions or with the value of your previous index. Okay, that is this plus 1. Whatever is higher, that I am going to update in my DP. Okay, so let's see it here. What I have done, I will be comparing now max What was the value of DPI? DPI is 1 only for this index. Okay. Now I will be comparing it with my this index value DP of J plus 1. That means 1 plus 1. So what is maximum? Maximum is 2. So I will be updating my DP array. That means now the new array will be this one. Okay. Now we will be going to the next element, that is the element 9. Okay. Now I am going to compare 9 with all my previous elements of the array. So it is being compared with 10 first of all. So 9 is less than 10. So there will be no updations. Again 9 is less than 22. Again no updation. That means the DP array is going to be this only. Okay. So we have done no updations till this point. Okay. Now we will be moving ahead with the fourth element, that is your 33. Now I am going to compare 33 with all the previous elements one by one. So what I'll do, 33 is greater than 10. So again we are going to check it. What is the maximum value? Maximum value at 33's element at the DP is 1 only. Okay. What we were having? We were having 1 only, the value. And at your jth index, that means at 10, the value was 1 plus 1 I will be doing. So what is the maximum value? Maximum value is 2. So I'll update this array with the value 2 here for the time being. Okay. Now 33 is compared with the next element, that is 22. Again 33 is greater than 22. Now again maximum we are going to compare whether it is your the current value of the index, that is your 2, or 2 plus 1. Why 2 plus 1? Because the value at 22, okay, this index at the DP array is having the value 2. So I am going to compare it with this value. So you will be having the maximum value of 3. So again I will be updating it with 3. So now the new DP array that has been created is, we are having 1, 2, 1, 3, and the remaining values are remaining as constant. That is the previous one. We have not changed it yet. Okay. That means the remaining values would be 1 only. Okay. So let me now remove this. Let me now just erase this. Okay. So that we can move ahead with the next element. Okay. Now we will be going with the next element, that is 21. Okay. So what I'll do now, 21 is being compared with 10 first of all, which is greater than 10. So I am going to see, like, the DP array is going to be updated now, and we will be checking the max of what? Either the DP of 4, which is the index of your 21, okay, or DP of 0, what was the index of your 10, okay, plus 1. Whichever is greater, that is going to be updated there. So the value of DP of 0 was 1 only, and the DP of 4 is 1. So the maximum value is either 1 or 2. So I am going to update it with 2 now. This is the maximum value. Now we are going to compare 22 with 21. So now guys, you can see that 21 is less than 22. So that means no updations will be there in your DP array. Again, it is being compared with 9. Okay, so 21 is greater than 9. Okay, so now in this case, again the updations will be done. That means it is going to check for the maximum value, okay, which is at DP of 4, or which is the maximum one. That means DP of 2, which was for the 9th, plus 1, which is maximum. Okay, that we are going to see. Again, we are getting it 2 only. So that means the value will be remaining as it is. Okay, that means the value will be 2 only by this point of time. Now we are going to compare it with 33 also. So 21 is again less than 33, so no updations will be done. So now the new DP array that has been created till this point will be having the value 1, 2, 1 for 9 and 3 for 33 was there. For 21 it will be remaining 2 because that was the maximum value which I got. For the remaining one it will be 1 only for the time being. Okay, now we will be going with the next element, that is the element 50. Okay, now I am going to compare it with all my previous elements. So 50 is greater than 10. Okay, so now guys, what I am doing, I will be again finding the maximum value. Either this is maximum or this is maximum. Okay, so this value was 1 and this value will be 2. Of course 2 is maximum, so your value will be updated to 2 for the time being. Okay, now guys, we are going to compare it with your 22. So 50 is again greater than 22 also. So again we are going to update the value. Okay, so 50 is greater than 22. So again it would be maximum of your DP of 5 or your DP of 1 plus 1. Okay, DP of 1 was having the value 2. Okay, so now I will be doing it 2 or your 2 plus 1. So whichever value is maximum, that is 3 is the greater one. So we will be updating it with 3 now. Okay, now it is being compared with 9. 50 is again greater than 9. Okay, but the maximum value at this point, okay, will be 3 only, because at 9 the value is 1, so 3 is greater than 1, so there is no point of changing it, so we will be keeping it 3 only. Now we will be comparing it with 33. So 50 is greater than 33 also. Now we will be seeing whichever is maximum. That means the current value of 50, that is the index DP of 5, okay, or the value at your third index, okay, that means 3 plus 1. So 4 is greater. So we will be keeping, like we will be changing this value to 4. Okay. Again we are going to compare it with 21. So 50 is greater than 21 also, but no updations would be required. We can see it here. The value at 21th index, the index of the element 21 is 2 and here it is 4. So of course 4 is greater than 3 because 2 plus 1 we will be doing here. So 4 is greater, so we will be keeping it this only. So the final DP array till this point is this one. Okay. Now we will be going with the next element. And we are going to compare all the values like this only. Okay, one by one. So we will be going with the next element, which is 41. So we are comparing 41 with 10. Okay, it is greater, so of course the values will be updated. Maximum we will be finding either at the index of this 41 or the value at your 0th index, because 10 was at the 0th index, plus 1. So whichever is greater. We were having 1 or 2, so of course 2 is greater, we will be keeping 2. Again it will be compared with 22, so 41 is greater than 22. Okay, so now your 22's value was 2. 2 plus 1 is 3, which is greater than this, so we will be keeping the maximum value, which is 3. Again we are going to compare it with 33. So 41 is greater than 33 also. Again we are going to compare it, because 9, again guys, 41 is greater than 9, but no updations would be required in this case. Again we are seeing for 41 is greater than 33. We were having the values 3 with us, okay, and 3 plus 1. So it will be updated to 4. The maximum value now will be going to be 4. Okay, again we are going to compare it with 50. So 50 is greater than 41. So there will be no updation. So final value here will become your 4. Okay, so that means now the DP array has become, after dealing till the 41st element, okay, that means the value of 41, okay, till DP of 6, we are having the value as, we are having the array as 1, 2, 1, 3, 2, 4 and 4. Okay, and the remaining two values are 1 and 1. So same ways guys, we will be comparing 60 and your 80 also. Okay, and we will be comparing it with all the previous elements. So final DP array after all the calculations would be this: 1, 2, 1, 3, 2, 4, 4, and here you will be having 5 and 6. Okay, so you can see the maximum length of the longest increasing subsequence is 6. Okay, so that means we will be printing the output as 6. So even if I'll run this code, you can see the output here. Okay, so you can see the length of my LIS is 6. So the code is absolutely correct, and we are understood like how the dynamic programming approach can easily and with the less complexity can solve the length of the longest increasing subsequence. So guys, this was a dynamic programming approach where we have reduced our complexity from exponential to the order of n square. There is an even more efficient approach, which is an optimized approach using the binary search, which reduces the time complexity to order of n log n. Guys, if you want me to make a video over the optimized approach also, please mention that in the comment. I will be definitely making the video over the optimized approach where we will be reducing the complexity of longest increasing subsequence to n log n. Okay, so there you have it. The longest increasing subsequence is a fascinating problem with the multiple solutions from the basic to highly optimized. Okay, try implementing these approaches and see how they work with the different data sets. If you enjoyed this video, don't forget to like, subscribe and hit the bell icon for the more algorithm tutorials. Thank you for watching and happy coding.